Let's start off by writing our prime numbers down. 2, 3, we go up in odd numbers. 5, 7, 9 is not because it's divisible by 3. 11's okay, 13's okay, 15 divisible by 5, 17's okay, 19's okay, 21 is 3 times 7, 23 is okay, 25 divisible by 5, 27 divisible by 9, 29. Okay, that's just up to 30. Now, we're interested in the smallest prime number that can be written in two different ways as the sum of three primes that are all different. If we use 2 along with another 2 primes, we're necessarily going to get an even answer because 2 odds add to give an even, which means we cannot use 2. The smallest total we could ever make with 3 primes, therefore, apart from 2, which we've rejected, so to get an odd number, is going to be 15. Of course, we're not going to be able to do that in two different ways because I've used the 3 smallest, but it does at least give me a little starting point. I can see that 3 to 13 isn't going to work. If I go with 3 plus 5 plus 11, then that is actually going to be the next biggest total, which takes me, in fact, to 19. So 17 is not going to be possible, but there's no other way I could actually then get 19 because I've already used 3 of the 4 smallest primes, including the smallest remaining one. So as soon as I, change it, I'm going to get a larger number than 19. So yeah, that one's not going to be achievable. Okay, so can we get 23? Well, let's try using 3. Then I need another 2 primes that add to 20. And actually 7 and 13 work. Okay, so I can definitely achieve it in one way using 3 different primes. If I try and use 3 in another 2 primes, it's not going to work. 5 would go with 15, 11 would go with 9. So that's the only way if I use 3. But what if I try and use the next biggest prime, 5? Now I need to achieve 18 to get to 23. And actually, this is obtainable if I use 7 and 11. So I've got 7 in both of them, and I've just got like a prime that's 2 bigger over here, but 2 less over here. And it does check out. So 23 is the smallest prime that could be written in two different ways as the sum of 3 primes that are all different.